Piecewise functions. This should be our second go-round at least with piecewise functions, maybe even third. But we struggled with them back in Algebra 2. It'll be so much better this time because it's our second go-round. Why is it called piecewise? Because there's two pieces to this puzzle. If you like to highlight, you're welcome to highlight. If you don't want to highlight, you don't have to. But you got two pieces. I have a green piece, and I have a red piece. And I think we're all very familiar with what this means. Doesn't that basically mean y equals right there? So what I ask all my students to do for piecewise functions, I need you to do this with me, is we're going to make baby tables of values. So to graph this piecewise function, we are going to totally take this part, the f of x, that's y equals, and it's going to equal x. Why x? Because that's totally what this says right here. That's the first piece of the puzzle. It's literally y equals x. Then I ask you to think about what that should look like before you even start graphing it. Is it a line, a parabola, a cubic, or a square root function? What is this guy, my friends? This is a line. Then you've got different types of lines. Horizontal, vertical, or oblique. Discuss. Horizontal, vertical, or oblique. What is this guy? This is oblique because it has both variables in it. It has an x and a y. So we're going to make a little... But we're not going to graph the whole line y equals x. We're only going to graph a piece of it because they have restricted the domain. Remember, domain is about x's. And they say, yo, bro, the only x's you can use in this green function is if x is greater than or equal to 2. So this home slice is called the critical point. This is a very critical value for this dude. He will be where we start our table of values. I'm starting with the critical number. And I got to know if this actually works in this function or if it doesn't work. Does 2 count or not count? This will tell you. What do you think? Does he count or not count? He counts. And remember, that's a closed dot when we graph it. So I've actually put a little closed dot here because sometimes we might have to make an open dot. But 2 works in the green function. So far, so good with me. Then I want to know, what are some more x values that are going to be on this graph? I either have to go bigger than 2 or less than 2. So a great question you had a long, long time ago was, well, how do you know if you're going bigger than 2 or less than 2? You just do what it says. It says the x's that work for Mr. Green Jeans here have to be greater than 2. So would you like me to pick the next x value to be 3, or would you like it to be 1? Isn't that greater than 2? And I'm going to pick another one, 4. So I'm going, 2 is the very starting point. This is where this is going to start from. He's included, and then I'm going to go bigger than that. And then to find the y values, some people had a hard time with that. They're like, well, how are you finding these y values? It's Algebra 1. If you know what x is, you substitute that into the equation right here and figure out what y is. So if x is 2, y be 2. And if x is 3, shouldn't y be 3? And if x is 4, shouldn't y be 4? Do you have a question of where those y values came from? Now, how to plot these points. Always plot the critical point first. And I know it's weird, but we're going to make him a fatty boom batty. Big, fat point. 2, 2. So 2, 2 is right here. The question is it an open dot or a closed dot, though? What is it? Closed. This is the only point that could possibly be an open dot. Everything else on this graph is going to be closed dots. But this was the one that we were just saying. Maybe 2 works, maybe 2 doesn't work. It does work. It is included. So please make him huge. Fat boy, the fatty boom batty. Then the 3, 3, we're just going to plot him as a normal dude. And the 4, 4, we plot him as a normal size. It's really weird that I want that first one to be fat, but if you do it that way, you'll never connect the dots wrong. You always start from the fat boy and go through the others. So take your straight edge, go from the fat boy through the others. Start from the critical point, he's the fat one, and go through the others. There are many people who connect the dots like this. Do you see how I could have connected the dots going this way in red? But that's the wrong direction because I didn't start from the critical point. So here is that piece of the puzzle right there. That is it. If you want to highlight whatever color you chose here, like green, highlight that piece green. If you don't want to highlight, I don't care. That's your choice. That took care of the top piece. If x is greater than or equal to 2, we're using this part of the function. Next one, I'll use my other color. This will be y equals whatever it says right here. And would you believe it's just a 2? So it's not a parabola, it's not a cubic dude, it's not a square root dude, it's a line. But you tell me, horizontal line or oblique? That's a horizontal piece because there's no x's with it. We're still going to make the little baby table, just a little guy. And I have to start with an x value. The x value that is critical to this dude is 2. 2 is where this is a very critical spot. But my question is, if I had an x value of 2, does it work in this red function or does it not work in this red function? Doesn't count. There's no equal to bar, so that's like an open dot, and I indicate that with just like I circle it. That's an open dot. And then the last thing is how to choose other x values. You know, people are like always wanting to go 3, 4, 5 right after that. You know, that's bigger than 2, but we don't want to choose x's that are bigger than 2. Don't we want to choose x's that are less than 2 in that case? So that would go 1, 0, -1, whatever. You don't have to have that many. And then we will totally start substituting in to find y's. That's really weird because there's no x's to sub into, right? So I just want to know what y equals on all of these. And obviously, guess what y equals, my friends? Because that's the equation of this line. Y equals 2. Every single time, y equals 2. To plot these points, I'm going to start from the fat boy. Start from the critical point and make him fat. It's 2, 2, which is weird because it's a green dot already. But I'm graphing the red one, and isn't he supposed to be an open dot, right? And that's weird, though, because it was around the green one, so it's kind of filled in. When you're just doing it in pencil, it's going to look like a closed-in dot, which is fine. But just realize on this piece, it doesn't work. And then I'm going to plot 1, 2, 0, 2, and the other ones, and connect them from the critical point through the others, a.k.a. through the fat boy through the others. And there it was. There was that horizontal line, but it sure wasn't the whole thing. It was just a piece of it. It was just a piece of it. If you want to highlight that red, or whatever color you're using, you can. This is such a weird thing for students to understand, and I get that, you know. But let me ask you a real-life situation. Let's use ages. Would you believe that something is different once you turn 18? Like, does life treat you differently when you turn 18? So on this graph here in red, this is like, just pretend like from 0 to 18, you know, not including 18. From 0 to 18, not including 18, you really have no adult responsibilities, you know, legally. But then from 18 forward, right? Isn't something different happen? You can totally be accountable for all your actions. That's what happens with these two pieces. This is like, yo, this is before I was 18. This is 18 and after, or whatever. You know, it's like things are different in that situation. Domain and range has been an issue for students, so I use the straight edge test. To do the domain, since the x's run left and right, you always start smallest. I'm going to start way over yonder at -infinity. And all I want to know is if either piece, I don't care if it's green or red, if it would run into this straight edge over here. Would that happen? Yes. So -infinity is part of this domain. And as I move to the right, as I keep on moving, I'm still touching part of the graph. I don't care if it's red or green. I'm still touching, still touching. Then I get to this weird critical area of 2. Is it touching a part of the graph? I don't care if it's green or red. Is it touching it? Yes. And then it keeps on keeping on, right? So would you believe that went from -infinity to +infinity? That was all real numbers are in the domain. Because one piece said 2 or bigger, the other piece said less than 2. There was nobody left out, you know. You invited everybody to the party. 2 or bigger or less than 2. It's just sometimes they had to go to the red house and sometimes they had to go to the green house. Range, though, was something that many students struggled with. Range is about your y values, and since the y-axis goes low to high, you're going to put your straight edge as low as it could possibly go, which is -infinity. Does either piece of this graph touch my straight edge down here? Nope, not touching, not touching, not touching. Where does it start touching the graph at? At 2. And is it included or not included? Well, that is included. 2 is included because it's nice and solid there. And then as I go higher, would you believe the straight edge is touching part of the graph all the way up to +infinity? So that was a very slow refresher just to kind of get you. Like I said, the second go-around with these is much easier than the first go-around. Questions about this one? Let's do another one. Let's color the pieces. If you're a coordinated person, you don't have to, but use the same organizational system. My first one was green, my second one was red, so I'm going to do the same thing. And now, this is a different one. We didn't do any of these in Algebra 2. But whatever the top piece is, we're going to say y equals that top piece. Preview what it's going to look like. Line, parabola, snake, square root guy. What is this guy supposed to look like? A line, but part of it, right, because we're cutting it off. And would you believe he's also oblique because it has x's and y's. So what part of the graph is going to graph? Starting from the critical number, where x is bigger than 1. Even though 1 doesn't count, right? I know it doesn't count because it doesn't have an equal to bar. You're starting your table with 1. And you're indicating on the graph with an open dot that it's not going to count. So 1 starts. And I have to decide if I want to go 2, 3, 4 or 0, negative 1, 2. Do I want to go bigger than 1 or do I want to go less than 1? Bigger than 1. 2, 3. That's enough. You just need a couple points. This is also going to look like a ray because rays have one endpoint. This only has one critical point. If there was 2 points, it would look like a segment. That has 2 total endpoints in that case because it ends here and it ends here. But a ray has one endpoint and goes on forever. So to find these y values, you substitute in. If you put 1 in for x, do you see how we get 6 out of that scenario? If you put 2 in for x, we'll get 8 and 10. Yes, no, maybe, on where those came from? Let's plot them. 1, 6, fat boy, open, because he doesn't count. 2, 8, and 3, 10. Connect from the fat boy through the other points. You will have to do these on your test, which is on paper. From the fat boy through the others. That one isn't a big deal. We've done that many, many times. The next one is different. I think we can handle it, though. It's going to be y equals 2x squared plus 2. Preview. Do you know what shape of graph this should look like? It's going to be a parabola this time. Open and up, because the a value is positive, but only part of it. So we're really going to need a juicy table of values to graph it, because the parabola, you know, it's got a different rate of change. Which point do we start with? This one. You start with 1, and he counts. So you're going to close him in. 1 fits into the red function. Then I got to pick x's less than that, so I'm going to do a bunch. 0, negative 1, negative 2, negative 3, negative 4. Why am I picking a bunch? Because this thing's going to curve around, and I got to figure out where that vertex is and see where the breaking point is. How to find all these y values? Use your graphing calculator's table of values. Punch this guy. Will Cami be loud when she walks in? No, she won't. Welcome back, guys. Just grab your practice sheet from last time. We're on the back side of it. That means you and your neighbor get this one done, please. 2 pieces. For those who just walked in, if you're not comfortable doing this right now, you can wait and watch the video at the very beginning to see how we did it, if you want to wait. But we're making baby tables of values. Maybe your neighbor can help you if you just sat next to somebody. And I didn't pause it. Sorry, guys. Pause it now. So the first piece, you had to pick where x was less than or equal to 1. So I started with 1. It's included. And then I picked some numbers less than that, made the first point, and I said fat, go through the other dots. So make sure we had that point in the right way. Second piece, 1 doesn't count. You got to have one x value is bigger than 1. And then the domain, going from left to right. The green thing will totally run in, and it'll just be all reals. But the low to high, if I bring this straight edge back, there it is. Couldn't find it. As low as I go, it's running into it all the way up to there. And it's about the y value, not the x value, so it goes to 2, and it's not included, so that's why we put the parenthesis. Okay? stuff we've definitely done before. A few new things. First, my bad, I have an extra one on here just to see. You tell me, tell your neighbor first. What is this piece going to look like? More like a line, more like a parabola, more like a snake, more like a what? What's that piece going to look like? What do you think? This is a line. Is he oblique or horizontal? He's oblique because this is a y, this is an x, and this is obviously going to make what? A parabola, but just a piece of the parabola. And here's what it would look like if you did it. Now, okay, let's go to this one. This is a weird dude. It's actually much easier than you think, but I need your help. How many pieces? 1, 2, 3, 4 pieces, right? Let's talk about this piece. I don't even need to write a table down or nothing like that. This is so simple. This says y equals 4. Do you know what that would look like? Line, parabola, or what? Y equals 4 is line. Horizontal or oblique? Horizontal. So it's going to look like a horizontal line, y equals 4, but not everywhere. It's only going to go from between 0 and 2, if my pen would wake back up. How about this piece? Horizontal line? How about this piece? And how about this piece? Nothing but little horizontal pieces. But the interesting thing is, they've got all these different restrictions in the domain with 2 boundaries. 2 different boundaries. X has to be between 0 and 2. If you have a horizontal piece with 2 boundaries, that doesn't look like a ray, doesn't it look like a segment in that situation? And this graph is going to make what's called a step graph, where the steps are like, all the little pieces look like steps in this guy. So how to make it on paper? You have to look at your x's to see what you want your x's to go up to. Here's all the crap about the x's. What's the smallest number you see in all of these when it comes to all the restrictions on our x's? 0. What's the biggest one you see? 8. So we got to go on the x-axis from 0 to 8. I'm going to start with 0, and I can't count by ones because I don't have enough spaces. So I'm going to go from 0 to 8. Questions? Why I did that? Y values. These are all the y values. Doesn't it say y equals 4, y equals 8, y equals 12, y equals 16? What's the biggest number we got to get up to? 16. We've got 5 spaces to do it. I definitely can't count by ones. Probably can't even make it by 2s. Let's go by 4s. Oops. 4, 8, 12, 16. Finish it. Let's look at this little piece. This is the line y equals 4 right here. I'm going to just grab the whole thing for it. Y equals 4. My pen is really not cooperating. Apologize. Y equals 4 looks like this. Don't graph this. This is y equals 4. They only want that piece between 0 and 2, though. Right? Just in between these two guys, in between 0 and 2. Right? So what we do is it's going to be a step. We go to 0, 4, and we graph that point. Should it be an open dot or a closed dot, though? What do you think? Closed dot. And then we go to 2, 4, because 2 is the bigger boundary on that, but should that be an open dot or a closed dot? Open. And everything in between there, any x value I pick in between there is also going to give me a y value of 4 if I made the table. But if I go to the next step, y is supposed to equal 8 between 2 and 4. So 2 counts. So if I go to 2, 8, I have to put a closed dot there because this had an equal to bar. And then I got to go all the way over to 4, 8, but it's got an open dot. And everything in between there. If you pick 3 and put it in, it's going to give you a y value of 8 back. If you pick 3.6, it's going to give you a y value of 8 back. Make the rest of these steps for me, please. Here's our 4 pieces, just like you told me. And it's kind of weird, but you see the step graph that's made. I just set you up. Never once am I asking you to make one of these on paper. Never once. I want you to look at what this graph looks like. Where are the closed dots at? On the left side or on the right side? I could have told you that before we started. Aren't all of these equal to bars on the left side of my domain restrictions, right? And the open dots are on the right side in that case. So when you get a multiple choice question like this on my math lab, this is the exact same problem. I want you to tell me which one of those four is the first one. There's no freaking way that this horizontal, 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 horizontal 4 pieces is which graph is automatically eliminated. B as in boy, out. Those are oblique little steps. Are you with me on that? Then you can look to see where the closed dots are supposed to be. On the left side, which choice can you eliminate now? D has all open dots on the left side, so that's out. But the interesting question that students have is, well, how do you know if it's between A and C? Because this has closed dots on the left, this has closed dots on the left, and they're all like horizontal steps. Well, when y is supposed to be 4, that's supposed to be between 0 and 2. Here's 0 and 2. Here's 0 and 2. Here's what y turned out to be. In this case, it turned out to be way up here at 16, and in this case, it turned out to be 4. Which one of those is the correct graph? Boom.
So when it comes to like reading these piecewise functions, they ask us to like complete the description. So there's 3 little pieces. You'll notice they're all horizontal. And check out this green piece right here. This green piece is like, remember these are like y, you know, so this is like y equals 2. That's like the horizontal line, y equals 2. But doesn't it have like 2 different boundaries? So if you just kind of look, if you take the boundaries down to the x-axis, because that's what we care about, is like what is the restricted domain on this guy? It's like what is it between on the x-axis? You see it's between -6 and -1. But you can tell because of the closed dots, you know, they're going to be included. So what we do is you got to read carefully on your homework is if they want it as an inequality or do they want it as an interval. They won't want both, so just read carefully. So I'll do it both ways. If they want the first one as an inequality, since there's 2 boundaries, x goes in the middle, and you'll always make these symbols like point to the left. You put the smaller boundary on the left side. The smaller boundary is -6. You put the bigger boundary on the right side, which is -1, and you decide if you need equal to bars. This dot is closed, so boom. This dot is closed, so boom. We get those as an inequality. From an interval, you just read it from left to right. It goes from -6 to -1, and that's both going to get square brackets because they're included. Otherwise, we put the parentheses. So read the question. Do they want it as an inequality or do they want it as an interval? But that's just one piece right there. Here's the next piece. This, I don't want that to be red. I want it to be orange. This -3 is like y equals -3. So looking where we trace that dog up to the x-axis, it's between -1 and 3. Like when you trace these dots up, you know, it's between -1 and 3. So as an interval, I'm going to go x in the middle, symbols point to the left, -3 is the smaller boundary. I'm sorry, -1. I said that wrong. -1 is the smaller boundary. Right when I trace that up, it goes to -1, and then 3 is the bigger boundary. This is an open dot, so that controls this arrowhead, meaning you don't put a bar on it. This one is a closed dot, so I do put a bar. And then when I write that as an interval, it goes from -1 to 3. This gets a parenthesis because it's not included, and that gets a bracket. So the final little piece right here, if you just trace those down to the x-axis to see where the x's are between, it's between 3 and 4. Again, there's 2 boundaries on this guy. So x is in the middle. Symbols always point to the left. Put your small number over here. 3 is the smaller of those. The guy that's on the left also. And 4 is the bigger number. And then we need an equal to bar on that homeboy. He's on the right side. And as an interval, that's from 3 to 4. 3 is not included. 4 is included. So be careful. Do they want it as an interval? Do they want it as an inequality? Moving on, our next question talks about, like, hey, it gives us the system right here with its piecewise. You got 2 different pieces here. I'll call this like my green piece, like we've been kind of doing all day. This first piece right here is the green piece, and the second piece is the red piece. It's about how many banks there are in the town of Meowville in the years 1945 through 2015. It's just like a little predictive thing. It's given by this function, where X stands for the years after 1900. Bada boom. What does this model give as a number of 1965? Well, since X stands for years after 1900, x is going to be 65 in this. Isn't 1965 65 years after 1900? So then I have to decide which piece this x value goes in. Well, it's about the restricted domain. Excuse me. If x is 65, it fits into the green piece. Do you see how x less than 80 right here goes in this guy? So all that means is I need to take 65, bada boom, and put him in for x into that function. So I'll grab my calculator and I'll take 70 times 65 plus that 13,250, and bada boom, 17,800 is how many banks there would be according to this function in 1965. When we do that for the next one, what does the model give as the number of banks in 2005? Remember, x is years after 1900, so 2005 minus 1900 is 105. 2005 has been 105 years after 1900. Which piece of the pie does this guy go in? Well, it's got to go in this pink piece right here because 105 is greater than or equal to 80. So putting 105 in for x into that function, I did negative 350 times 105 plus that big old y-intercept, and I got 10,870 would be the answer to that one. So it's just about in the piecewise function, figure out what your x value is, and it can only fit into one of these. You know, that's why it's piecewise. It's like, hey, if x is less than 80, we're going to use the green piece. If x is greater than or equal to 80, we use the pink piece. On this one, they just ask us to read these guys. So here's kind of what I'm looking at. They say, dude, find f of negative 2. Remember, these are x values. You know, it's like f of x. Total x values in this case. So I'm going to go to negative 2 on the x-axis because they're asking me to find f of negative 2. And just to kind of show you, like, I'm going to use a line is what I'm trying to do. All of this is like where x equals negative 2. I need to just see where my little red segment touches the blue graph, and it kind of looks like it's touching it in two different places, like right here and right here, but it's not actually doing that because isn't there an open dot there? It's only touching the function at this blue dot right here, and they want to know like what the y value is. So when x is negative 2, this guy right here, bing, is negative 1 on the y-axis, right? Just kind of reading that graph in that case. So obviously you can't draw on your computer screen, but when they want you to find f of 0, you're just literally looking like when x is 0. So it's just like, okay, I'm going to go from 0 and trace down to like where that touches the graph at. Sorry about that. You know, where it touches the graph at. It touches the graph right there at negative 2. Like, what is the y value in that case? So then the last one of those is they're like, okay, what about f of 3? So you just look at where x equals 3, you know, and you just like go find out where it touches the graph at. And remember, it's only in that one spot. It's also at negative 2. It's totally cool to get a couple answers that are the same in this case. So no big deal there. And then finally, they'll have a question like this where you've got to fill in the part of the function and the restrictions in the domain. So a museum charges $4 per person for a guided tour with a group from 1 to 7 people, right? So if you've got a group coming into this museum, right, for the group is if it's anywhere from 1 to 7, it's going to be $4 a person. So watch out that you're using the right letters on homework. You know, a lot of people have been using X's. We want to use N's for the number of people. So how do you feel about that first part being $4 times every person, right? N is the number of people showing up, and every one of them has to pay $4. But that's only true if the number of people, do you see how this says is bigger than 0? So that takes care of 1, and then wouldn't it have to be less than 7 in that case? You know, that's not actually right, Mr. Faunus. It would be less than 8 because I do want the 7th person to be in there. So that's kind of weird. You'd think you'd put a 7 there, but we want to put an 8. How did I know that? Because this is not included in that case. If I would have put a 7, he doesn't count in that spot. So every person in a group from 1 to 7 people, right, that's like between 0 and 8, not included, pays $4. But man, if you got a big group coming in, you know, if there's more than that, you're just going to pay $32 for any group that's bigger than 8. So this is like what you pay. Remember, this is going to be the 32. And then if the group is greater than or equal to 8 people, you know, that's where it says 8 or more, you're going to just pay $32 in that case. So that's kind of a weird one, man. Let us know if you have any questions, right? Some of these are hard to like figure out how to graph, so come on in and we'll help you. But have a good one.